In this video, we're going to cover 7.4 trig equations. And we're specifically going to be focusing on solving trig equations where the angle here is just x or theta, something like that. Okay. We will eventually, in 7.5, look at questions or equations where that angle is maybe something like 2x minus 3 or something like that. The angle might be a little more complicated. All right. And so in this first one here, it says to solve the trig equation and to give all the solutions. So it's going to end up that our trig equations have lots of solutions. Okay. And we'll see that that's the case here in a second. So to do this, if you end up with something over here that looks like one of those x or y values that we're used to seeing on our unit circle, then you can actually just use your unit circle. And so we're going to do just that. We're going to look for on our unit circle where sine is equal to the square root of 2 over 2. So if I come over here, sine is the y value. So I'm looking for these two locations here. So that's, oh, I circled the wrong one. Here we go. These are the two spots where sine is root 2 over 2 on our unit circle. Okay, so let's record those pi over 4 and 3 pi over 4. Let me hit the right buttons here. There we go. So we have, again, pi over 4. And we have, and actually I'm going to write it right below. I want to leave room for something else here. Okay, so these were the two angles. But now anything that's coterminal with these angles will correspond to the same y value on the unit circle. So in other words, these angles plus 2 pi k these are going to be actually all of our solutions to the equation. There's actually an infinite amount. Okay. Now, I won't make you write this, but this is technically for when k is an integer. And the shorthand for that is you have this kind of sideways looking e thing here. And then the z here means the integers. But you could write that in words if you wanted to. You could say for k or where k is an integer, or you could write it in this mathematical notation here like this. But again, I won't actually require you to say that k is an integer. I'll just expect that it is when you write your answer. Okay. Now, this is great and all. This is how every single solution to this equation is of one of these two forms. Well, let's say that we are looking for some specific solutions. Okay. Let's say that we want to find the solutions on the interval from, say, 0 to 10. All right. Then is what we could do is we could figure out which of our solutions are actually from 0 to 10. And so is what I want to point out first here is with, say, this first equation, if you were to let k be a negative number, we'd end up with a negative angle here, which is not going to be in the interval 0 to 10. Okay. And so I'm probably going to erase this here in a second, but here's the idea of what I was saying here. If we were to, let's say, k be minus 1, then we'd end up with what? Pi over 4 minus 2 pi. Okay. Which, if we got a common denominator here, we'd have pi over 4 minus 8 pi over 4. So this would give us minus 7 pi over 4. Okay. Well, that is not in between 0 and 10. Okay. It's negative. Okay. And the same thing will happen here if I try a negative value on this one. I'll get a negative angle x. Okay. So the first viable option here for k that would give us an angle between 0 and 10 would actually be k equals 0. Okay. So if I let k equal 0 for both of those formulas, I'd have pi, let's say for this one here, I'd have pi over 4 plus 2 pi times 0. Let's just pi over 4. So I'm going to start listing these out. Okay, and let's verify that pi over 4 is between 0 and 10. Some of you might be well aware that it is. It's actually going to be smaller than 1 here. Okay. And if I use this formula down here and let k be 0, I'll get x equals 3 pi over 4. And again, we can verify that this is between 0 and 10, or find out that maybe it's not, but it should be. There we go. We're getting this 2.3 something. And we can keep going here, though. So next, I'm going to add a 2 pi. I'm going to let k be equal to 1 in each one of these cases for our next set. We just tried k equals 0. Now let's try k equals 1. Okay. So I could, actually, I could shortcut this. I could just say 1/4 plus 2, just leaving out the pi's. And what that gives us, 9/4. So I'll end up with a 9 pi over 4. And we actually have the decimal approximation. Oh, no, we don't. Let's see what this is approximately equal to if I include my pi. So this is still less than 10. Okay, so this is a good answer. Okay. Let's use this one at the bottom here. So my 3 pi over 4. I'm going to leave out the pi, though, for a minute, so I can get my fraction here. So this one will be 11 pi over 4. Let's see if I multiply this by pi, if this is still between 0 and 10. Okay. It is. Okay, so 11 pi over 4 would be another one. All right, and let's check one more here. Let's see now if we let k be equal to 2, what happens? All right, so if we do that, then we have our pi over 4, which I'm going to just type in as 1/4, plus 2 times 2 pi, or how about let's just say 4. So we get this, and we want to multiply that by pi. And we can see now we are now exceeding, we're exceeding 10. Okay. And the same thing will happen if I try this with the 3 pi over 4. 3 pi over 4 plus 2 pi. And then if I let k be 2, then I need a times 2 here. And you can see that that's bigger than 10 as well. Okay. So if we were looking for the solutions on the interval from 0 to 10, these would be our 4. Okay. And so is what I want you to do every time you solve a trig equation is to first find every solution, like we did here. And then if you're asked to actually find the solution on some specific interval, you can use your little formulas over here to come up with the specific solutions that you're actually looking for. So, but this over here on the right was technically not part of the question. That was just a side note, that if we want, we can actually use these formulas to, again, get specific solutions. All right, let's give it, or actually, before we move on, I want to make another side note here. Okay, so if we were looking for the solutions on 0 to 10, and we're looking for the exact solution, this is what we'd want to do. Okay. But let's say we don't need the answers to be exact, just approximate. If that's the case, then we can actually use the calculator. Okay. And so is what I would do on my calculator if I were going to try to solve this equation on 0 to 10, let's say again. I'd plug this in and let this be y1, and I'd let this be y2, and I'd find their intersections. Okay, and so I'm going to show you how to do that right now. Okay, so I'm going to make this bigger. Let's hit y equals. So one of the sides was sine of x. The other side was, I believe, the square root of 2 over 2. Okay, now again, I'm going to graph this to look at their intersections. So before I go any further, I also want to make sure I'm in radians, so I'm going to hit mode. I am in radians, which is good because we solved this equation in radians, even though the question actually didn't specify whether to be in radians or degrees, but I chose to go with radians. From here, let's hit the window. So we only want to see the solutions from x equals 0 to x equals 10. And in the y direction, sine only goes from -1 to 1. So I could leave it like this, but the square root of 2 over 2 is a positive number. So how about we just go 0 to 1 here in the y direction? All right, and then we can go ahead and we can hit graph. Okay. And you can see there are 1, 2, 3, 4 intersections, which means that there are 4 solutions, just like we had here. Okay. And we can check these. If I hit second and then trace here, I can go down to number 5, which is intersect. Okay. And you can technically just hit enter twice for these first 2 steps, but they're asking you for the first curve here. So just arrow over a little bit until you can see what curve your cursor is on. And so I'm just arrowing until I can see it. Okay, so I can see that it's on one of the curves that I care about. Okay. So I'll hit enter. Okay. And you can see it automatically moved me to the second curve, which is the square root of 2 over 2. And I can just hit enter there. Yeah. If you only have 2 curves, that step of letting your calculator know the first curve and the second curve, again, it's going to automatically put it on the 2 you want. So you can actually just hit enter twice. It's only if you have like 5 or 6 things in your y equals and you need to let the calculator know which of these curves do we care about their intersection. But again, for most of the time when we do this, we're just going to have 2 in there. So you can hit enter. Now, for the third question, guess, that the calculator is asking us, we want to arrow over to one of the solutions that we're looking for. Why don't we find the smallest one? And hopefully that's going to be pi over 4. So I arrowed over to it and I'm going to hit enter. And you can see I'm getting this 0.785 approximately for x. That's the value I'm looking for. Okay. And remember, that should correspond with this first solution, pi over 4. And if you want to check, you can look at the decimal approximation. Okay. And that is the same decimal approximation that we had seen in here when I used this tool. There we go. And then if I want to find the other 4, I can, or the other 3, I can go through the same process and find those on the calculator. Okay. So this is a great technique, again, when we don't need the exact value, okay, because the calculator can do this easily. Okay. And in fact, we can solve any equation that we're going to encounter. We're going to be able, at least in the next year or so, we're going to be able to solve like this if we wanted to. Okay. Again, just sometimes the downside is we're not getting the exact value. We're just getting the decimal approximation. Okay. All right, so let's move down here. And so now that we've finished 2 side notes, let's do some more of these questions, okay? So one thing you might have noticed in A is we already had our trig function equal to something that we're used to seeing on the unit circle. Okay. So the hope is that the same thing will happen with all these, even though they look a little bit different. Okay. So for instance here, I'm going to try to isolate cosine of x. So the first thing I want to do is subtract by the square root of 3 on each side. So I have 2 cosine of x is equal to minus root 3. And then I could divide each side of the equation by 2. And so I get minus root 3 over 2. There we go. And so now I just need to find on the unit circle where this happens. Okay. Let's do that. Okay, and we're probably going to find 2 spots again. Okay. Sometimes there is only 1. Okay. But most of the time there's going to be 2 when we're talking about sine and cosine here. So let's go find minus root 3 over 2 for the x value. So let's, right here is one of them. And the other one is right here. So we have 5 pi over 6 and 7 pi over 6 are 2 angles that make cosine equal to minus root 3 over 2. So let's go record those. 5 pi over 6 and 7 pi over 6. And then plus 2 pi k. There we go. So these two formulas here represent all the solutions to this equation. Okay, and remember that plus 2 pi k is just saying that not only does 5 pi over 6 and 7 pi over 6 work, but anything that's coterminal with them will work as well. All right. So next, we're going to look at tangent here. And I want us to do the same thing again. Try to isolate the trig function. So I want to get tangent of x all by itself. Okay. So one thing I'm noticing here is if I maybe subtract by 2 tangent of x on each side, then I'll just end up with a single tangent over here on the left. And now I already have my trig function isolated. That actually didn't take as much work as it looked like it was going to. Okay. Now here's the next thing is we need to remember what ratio of y over x from the unit circle will give us a square root of 3. Okay. So just as a refresher here, the best option here would be if y was the square root of 3 over 2 and x was 1/2. So this is one option. And let's just verify that it works. And yeah, that gives us root 3. So this is one option that would make tangent of x equal to the square root of 3. But also keep in mind that if these were both negative, that would also make tangent of x equal to root 3. So there will be two spots on the unit circle where this occurs. Okay. So let's go find those two locations. And then is what we're going to find is that we actually only need one of these two formulas when we're working with tangent or cotangent. Okay. So back to the unit circle, I'm looking for root 3 over 2 as my y. So that's right here. Okay. So that's one option. The other option is where both of these numbers are negative, which is somewhere down here. Again, I'm looking for y to be minus the square root of 3 over 2. So that's going to be right here. If I do y over x here or y over x at pi over 3, they're both going to give me that tangent is the square root of 3. So let's go record those. Pi over 3, 4 pi over 3. And then we were adding 2 pi k for kind of two reasons up here. One is that these angles are coterminal, but also the period of sine and cosine is 2 pi. Okay. With tangent, its period is actually just pi. So I can just add pi k. Okay. And now these seem like they're going to give us two different sets of numbers. Okay. But if you actually go into your y equals here, and I want to type in each one of those two formulas, I'm going to have to use x in place of k, but I just want to show you all something here. So if I go, so again, these are these two formulas that are supposed to give me every solution to the equation that we had. If I hit second and graph to look at the table, notice that along the diagonal, so like here in this one, you see this 35.605. If you look up and to the right at the second list, you see that same number. Okay. And if I scroll down to 38.746, again, if you look up to the right at the next list, you'll see that same number. So both of these lists produce all of the same numbers. Okay. So you only need one of them. Okay. And the reason that they produce the same list of numbers is that if you were to say let k equal 1 here, then you get pi over 3 plus pi, which is 4 pi over 3, which is this angle here. Okay. So yes, this is unnecessary to have 2. I'm going to get rid of this one, and I'm just going to box our 1 answer. But I do want to note over here that I should probably say plus or minus, plus or minus. There we go. All right, so yeah, that's it for that one. Okay. So basically, is what we're gonna see is most of the time with sine, cosine, secant, and cosecant, most of the time we'll have 2 formulas, and then for tangent and cotangent, we'll typically have 1 formula. But let's give this cosecant one here a try. So I never try to isolate cosecant, secant, or cotangent. Is what I'm going to do is I'm going to rewrite that cosecant as a 1 over sine of x. And then I could multiply. I'm going to try to isolate sine of x, by the way. I could multiply both sides here by sine of x. And then I could divide each side by minus a half. And so I get sine of x is equal to minus 1/2. And so then we just need to go find on our unit circle where this happens. So we come over here. We're looking for where the y value again is minus 1/2. So it's going to be below the x-axis. That's going to be here and here. These are, or maybe I'll circle the y value. There we go. Those are both minus 1/2. So we have 7 pi over 6 and 11 pi over 6. And then everything that's coterminal with these 2 angles. Or if you don't want to think about this as being coterminal angles, you can just note that the period for cosecant is 2 pi. So if we add its period or a multiple of its period, it's going to give us an angle that will have the same, when you input it into cosecant, we'll have the same output, which will be minus 1/2. Or minus 2. Minus 2. All right. So now we've kind of done the basic ones here. I next want us to try to solve some that either require factoring or the use of a trig identity. Okay. But again, you can see the angles in here are just x. None of them are 2x or 2x minus pi. They're just x. So let's zoom in here a little bit. And let's see if we can factor this. So I'm just going to use guess and check. This already looks like a quadratic. Okay. And maybe it might help if I rewrite it like this. 2u squared plus u minus 1. So if you were to try to factor that, I would start off with a 2u here and a u here, because I know when I multiply those, it'll give me 2u squared. I would like to end up with a negative 1. So I know I need a 1 here and a 1 here. And now one of these needs to be positive, one needs to be negative. And I don't know which one, so let's just try a plus here and a minus here. So if we were to FOIL this all out, we get our 2u squared minus 2u plus u. So that'll give us a minus u, not a positive u, which means that this is probably going to get it done right here. So let's check again. 2u squared. 2u minus u is just a single u. And then, of course, minus 1 times 1 will give us negative 1. Okay. So we factored it through guess and check here. You could also use the AC method or really the quadratic formula. But let's go ahead and write this out. So instead of u, though, we're going to use sine of x. So it's going to be 2 sine of x minus 1 times sine of x plus 1 equals 0. Okay. And so then the question becomes, well, now that we factored it, why was that helpful? Okay. Well, it was helpful because we weren't going to be able to isolate our trig function. We had two of them. And in fact, one of them was squared. Okay. But when we do this, when we factor it and it's set equal to 0, okay, is what this means is that any solution here is either going to have to cause this factor to be 0 or this factor to be 0. So this gives us two equations that we need to solve. Either this is 0 or this is 0. Okay. And so let's start working on solving this one here for sine of x. If we do that, we're just going to get sine of x is equal to a half. And if we solve this one for sine of x, we get sine of x is equal to -1. So this is going to give us an extra equation or two to describe all of our solutions. Okay. So let's start that process. So let's find where sine is 1/2. So looking for a y value of 1/2 on our unit circle. Let me zoom out. So here and here. So pi over 6 and 5 pi over 6. And then, of course, anything that's coterminal. And then lastly over here, we are looking for where sine of x is equal to -1. And there's only one spot on the unit circle where we have a y value of -1, and that is all the way down here. And this is at a angle of 3 pi over 2. So let's go record that. So here is all of our solutions. And again, if we're looking for specific ones, we just need to plug in values for k. And they need to be integers, meaning they're numbers like -3, -2, -1, 0, 1, 2, 3, and so on. Okay, so essentially the whole numbers and their opposites. Okay. Um, so next, let's take a look at the next one. And I see that there is a term that pops up twice here. It's that cotangent squared. Okay. So is what I'm going to have us do with this first is get those cotangent squareds actually on the same side of the equation. So in other words, I'm going to subtract by cotangent squared x on each side of the equation. And now I have this common factor of cotangent squared that I can actually factor out. And this factoring has helped us actually in the exact same way that it helped us in the previous example. If we have a product of things equal to 0, then solutions are going to come from either of the products being equal to 0. And of course, this one, we don't even have to solve it. Versus this one over here, maybe we should solve it for sine of x. So, all right. So let's find where sine of x is equal to 1 first. That will probably be easier. This actually happens at the top of the unit circle. So that's at pi over 2. Now, I want to point out something. We want it to be the case that if we plug this in, it makes this equation true. Meaning we get the same number on the left hand and right hand side if we plug in pi over 2 or pi over 2 plus any multiple of 2 pi. Okay. Well, Cotangent, just as a reminder here, cotangent of x can be thought of as cosine of x over sine of x. So it is what I'm trying to be really careful about here is I want to make sure that these numbers here don't cause any division by zero. Okay. And well, they don't cause division by zero because we know that if I plug in these angles here, well, sine will be equal to 1. Okay. So if these happened, these angles here, if they happen to cause some division by zero here, it would make cotangent undefined, and it would mean that these are not solutions. Okay. However, everything worked out fine. These will be some of our solutions here. So next, we need to find where cotangent of x is equal to 0. Okay. Let's go ahead and do that. So remember, if we are on the unit circle, I'm going to use theta here instead of x, but cotangent of theta, right, is x over y if we're thinking about our unit circle. So if we want cotangent of theta to be 0, is what we really need is we need the x value here to be 0. Because then you'll get 0 over y, which is 0. So the x value is 0 in two places. We have here and we have down here. But remember with tangent and cotangent, you only actually need to write down one of the two angles here. So I'm not going to use the 3 pi over 2. I'm just going to use the pi over 2 up here. Okay, so I have pi over 2 plus 2 or plus pi k. Right? The period for cotangent is just pi k. Or the period for cotangent is just pi. So all of our solutions are going to take this form here. Now, these two lists are almost the exact same. Okay. Um, but notice that everything that would be a solution using this formula would also be a solution via this formula. Okay. I can get all the same numbers out of this first formula as I can from the second, but the first will have more numbers than the second one will, okay, roughly speaking. Okay. So I could write both of these down, but it would be unnecessary because they all are encompassed with this formula here. So I'm actually going to unbox this, and this right here is all we need for our answer. Right. So next, let's try out G. So you can see here with G that once again, we're not actually going to be able to isolate our trig function. But so you can mess around with this a little bit and you'll probably eventually get stuck. And there actually is a trick here. So you might remember that sine squared x plus cosine squared x is equal to 1. So is what I'm going to do is I'm going to square this because those two terms will come out. There will be an extra term in here too. And maybe, just maybe, we might not actually be able to finish this one yet. We might have to talk about how to finish this in the next video, but let's at least get it started and see what happens here. So again, I'm just squaring each side. Okay. And so I'm going to get a sine squared x plus, and remember, we need to FOIL here, okay? FOIL. So I'm going to end up with a 2 sine x cosine x in the middle, and then a plus cosine squared x. Okay. Then, from there, I have on the right-hand side that I have root 2 squared, which is just 2. And then from there, I know that this thing plus this thing squared is just 1. So now I have 1 plus 2 sine x cosine x is equal to 2. Okay. And then we could subtract by 1 on each side. And then 2 minus 1, that's just 1. Okay. And now we're still kind of stuck. We still have two trig functions. Okay. Well, it ends up that there is an identity that's really helpful here. 2 sine x cosine x. Well, that's just equal to sine of 2x. And this is equal to 1. Okay. So you can see the angle I have in here, though, is no longer just x. Okay. So for now, I'm just going to say dot, 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 and we will figure out how to solve that the rest of the way through in 7.5. Okay. But is what I want to be evident here is that sometimes you not only do you need just a little bit of algebra, but you might need to factor. You might need to use a trig identity in order to solve that trig equation. But all of these ones that we've done through far, A through G, these all had on the right-hand side of the equal sign eventually some ratio or some x or y value that we're used to seeing on our unit circle. Okay. So then the question becomes, well, what do we do? Say here in example 2, where I'm not used to seeing minus 4/7 on the unit circle. I don't know what angle corresponds with that. Well, then you're going to need to use your inverse trig functions. In other words, is what I'm going to do here is I'm going to say x, and I'm going to say, oh, how do I want to do this? I was debating on whether I want to call this x1 or x2. I'm going to call it x1. So I'm going to say x1 is equal to cosine inverse of minus 4/7. And this does say to round it. So I'll go ahead and I'll round here. Okay. So if you make sure your calculator's in radians, I'm going to solve this in radians. Okay. So if I take cosine inverse of minus 4/7, I get roughly 2.1790. Okay. Now remember, anything coterminal with this will also be a solution. So I'm going to include here, I'm going to say that some of our solutions are approximately equal to 2.1790 plus any multiple of 2 pi. Now, this isn't the only solution. Okay. If we were to actually make a sketch of this angle that we just got from cosine inverse, there we go. It is going to be we need to think about whether it's going to be in quadrant 1 or quadrant 2. Well, cosine inverse to begin with only gives us angles between 0 and pi. Okay. And cosine is positive in this quadrant and negative in this one. So since cosine's negative here, we know that we're going to wind up over here in the second quadrant. And I want to make that look a little bit straighter. Here we go. So here's our angle. Okay. And I'm going to place a unit circle on this, but this would be our x1. All right, there we go. And I want to have this a little bit better color coded. All right, so we have some of our solutions still. And I said I was going to place a unit circle in here. Let's do that. There we go. And so remember, cosine is the x value on the unit circle. So there is actually another spot on your unit circle that has the exact same x value. And so if I just move straight down here, I can sketch in this new angle, which I'm going to need to adjust here. That didn't come out perfectly. There we go. That's much better. Okay. So we're going to be looking for what we need to do to rotate all the way over here to this spot, x2. Okay. So to find x2, we could just simply take, or actually, I want to point out something here. Um, this little bit of angle right here is the same as this bit here. Okay. And so I'm going to actually have us find this first. Okay. I'm going to have us find that first because I'm going to add that to pi to get what x2 is. Okay. So let's go ahead and try to write that in here. X2 should be equal to pi plus, and then this is going to be strange, but to find that little bit right here, I would actually do uh, pi minus x1. Or maybe I could just say, yeah, I'm going to leave it as x1. Okay. There it is. So yeah, pi minus x1 will give me that little angle there. And so if I add that to pi, again, that'll give me x2. Okay, so let's go ahead and get this in the calculator here now too. So let's see. We had our cosine inverse of -4/7. This is our x1. And so if you kind of look at our work for x2, right, it is pi plus pi minus that angle right up above there. Yeah. And so I'm getting roughly here about 4.1041. 1041. And so there's x2, which means that our remaining solutions here are going to be approximately equal to 4.1041 plus any multiple of 2 pi. So let's go ahead and give another one of these a try. Okay? But a sketch is always helpful on these. So this time we have a trig function that's being squared. Okay? But let's just begin by isolating that sine squared x. So in order to do so, I could just simply add the 1 over and then divide by 7. Now, in order to isolate sine of x, I actually need to use my square root property. And so I'm going to end up with kind of two sets of solutions here, because sine of x could either be equal to the positive square root of 1/7 or the negative square root of 1/7. Okay. And I think I'm going to add actually an intermediate step in here. So yeah, this would look like sine of x is equal to plus or minus the square root of 1/7. And if you wanted to, you could rewrite that as plus or minus 1 over the square root of 7, since the square root of 1 is just 1. Okay. So yeah, this is going to give us two situations here. Let's write it like this. Let's say sine of x is equal to 1/7 and is equal to the positive 1 over the square root of 7. And the other one is equal to minus 1 over the square root of 7. Okay. So in both of these cases, when we go to take the inverse, we're going to be missing one of the other angles. Okay. So let's go ahead here and go ahead and take our inverse. And so maybe I'll call it again x1. And I should actually say equal to here. I'm going to call this one actually maybe x3. Yeah. And we will round these values to 4 decimal places because that's what was asked of us. So we have sine inverse of 1 over the square root of 7. And so we're getting about 0.3876. And then let's try out the other one. So this one will be just with a negative in here. So we get minus 0.3876. There we go. Okay. Now here's the hard part is we got to find those other the missing angles here. I want to make us a little sketch of each one of these so that we can find x2. And I do need a unit circle. There we go. All right, so we got our 2 unit circles. Let's start off with sketching x1. So x1 is a quadrant 1 angle. This is a number that is, and by this number I mean this one. This is a number that is less than pi over 2. But also, when we talk about sine inverse, it can only give us angles in quadrants 1 or 4. And if sine of x is equal to a positive, it means that the angle that we're going to be looking for is going to be in quadrant 1 here. So we could go ahead and make a sketch of the angle. Okay. Now, sine is the y value on the unit circle. So I want to find the other spot on here where we have the same y value. And let's just sketch this one in orange. There we go. Okay, so that's the angle that we're going to be looking for. Okay. So to find that, again, note that this is pi units out here. And I also want you to note that actually this little angle right here is actually also x1 because of the symmetry of what's going on here. Okay. So if I want to find x2, I most certainly can. X2 should just be equal to pi minus x1. Let's go figure out what that would be. So this number right here on my calculator is x1, and if I do pi minus that, I get my new angle here, which is about 2.7540 radians, 754. And so we'll be able to write all the solutions that come from sine of x equal to 1 over root 7. And here in a minute, we're going to have to deal with this one. So let's just go ahead and record our answers here for this set. So we had that x could be approximately equal to 0.3876 plus any multiple of 2 pi. Okay. We also have, maybe I won't box that yet. We also have this 2.7540 plus 2 pi k. Okay. So there's half of our solutions. We're going to get the other half here in our second sketch. Okay, so this time you can see sine is actually giving us a negative angle, which means that we should be down here in quadrant 4. Okay. Again, it's a negative angle. Okay. This is x3. Okay. Now, again, there's another spot on our unit circle that's going to have this exact same y value. If I scoot over this way, I'll end up there. And so this angle here is what x4 is going to look like. But do note that this little bit right here is the same as x3. Okay. So I'm just going to do pi plus x3, but I do need to be a little bit careful because x3 is negative. I want the positive version of it. So my x3 here is going to be equal to pi, because right, it takes pi radians to get to here, plus the absolute value of, oh, I'm writing in the wrong thing here. There we go. X4 is equal to pi minus, or sorry, not minus, plus the absolute value of x3. There we go. Actually, that minus would have worked there if I left out the absolute value, but this is how we're going to compute it. Okay, so let's go get that x3. So x3 was this right here. I just need to insert the negative. I said we want to take the absolute value of that. You can just simply multiply this by -1 and it'll give you what the absolute value of that number was going to be. And then I could add pi to that like we said we were going to. And so we're getting here about 3.5292. Just double check that. Okay. So yeah, we're getting that. So now we have those two angles that we can add any multiple of 2 pi k to. And just because I can see it right now, I'm going to write in my solutions based on x4 here first. And add any multiple of 2 pi. And then our other one was minus 0.3876. There we go. And so this right here wraps up section 7.4.